Hello, everybody. My name is Paul Miller, and I'm a product marketing engineer at Texas Instruments. Today, I'll be going over optimized protection for input power with the TPS1641. So in terms of an agenda today, first we'll start to talk about an overview of power switches and what's in power switches. Then we'll dive into specifically of TPS1641 overview to talk about some of its key features such as power limiting, current limiting, and protection against single point failures. And then we'll touch on industrial applications for power limiting. So those in home appliances, medical, and building automation. And then we'll touch on one last application, backplane power protection for factory automation systems. To start with an overview of power switches, we have many different devices that fall underneath the power switches umbrella. And really, we have different versions which can help protect your inputs, provide power distribution through your boards, as well as provide output power protection to off-board loads and into other PCBs. Today, we'll be focusing on eFuses and hot swap controllers in this presentation. Before we go over to our eFuse content, I just wanted to provide an overview of what the difference is between a hot swap controller and an eFuse. The main difference between a hot swap controller is this device controls an external FET and provides a lot more flexibility in terms of the RDS-on of your FET. The eFuse, on the other hand, provides a very optimized solution, which can help you to save board space and cost in the system. But in terms of protection features, the devices offer the same protection. Within our eFuse portfolio, we actually have two different types. We have eFuses with single FET topologies, which just have one integrated MOSFET, and then we also have versions with back-to-back MOSFETs, as shown here. Today, we'll be focusing on a device that has a single FET topology. So taking a look at our eFuse and hot swap portfolio today, as mentioned before, our hot swap controllers have the ability to use an external FET, so the amount of voltage and current they can cover is quite wide. So what we're trying to do here at TI is actually increase the coverage of our eFuses to match that of our hot swap controllers. So in terms of less than 30 volt eFuses, we have a pretty wide variety of devices that can operate up to 200 amps when used in parallel. And then out of the 60 volt family, we have versions that can hook up to 6 amps today. And then something else that we're working on is our 40 volt eFuse. And today we'll be talking about the TPS1641, which comes from our 40 volt eFuse family. So looking at an overview of the TPS1641, this device has in total 8 different variants of the device, and it's a 40 volt 1.8 amp eFuse. So the device offers different adjustable current, adjustable power limit, as well as different fault responses, auto retry or latch off. The device also offers versions with in to out short detection, as well as adjustable overvoltage protection and soft start. The device is available in a 3mm by 3mm VSON package, and the device has 0.5mm pitch. So now we'll go into some of the specific key features of our eFuses. The first feature that we'll talk about is the power limiting of the device. So there's 4 different ordables which have this power limiting. Versions 1.0, 1.1, 1.4, and 1.5, which offer adjustable power limiting. The power limiting is adjustable from 2 watts up to 64 watts via an external resistor on the P-limit pin, shown in the diagram to the left. The devices also offer configurable blanking time for the power limit and overcurrent protection to allow transients to pass. So this could be such as a motor or a solenoid, which requires a high stall current would be an enabler. The blanking time for the power limit can be either set to 0, so immediate, or it can be set to a larger time corresponding to the C delay capacitor that is placed at the P delay or I delay pin. And this figure below shows how that can be configured. So initially, the device will allow a higher amount of power to be transferred to the load. And after the blanking time has expired, then they'll start to limit back to where the value is set. The device offers short circuit protection. So if it goes above 2x the power limit, then our device will immediately shut. So traditionally, in the past, what's been used to do power limiting has been PTCs, or positive temperature coefficient fuses. So these devices, as it says in the name, is related to temperature. So with that being the case, they can actually vary pretty substantially in terms of when they actually trip, depending on what temperature they're operating at. So if you look at the figure to the left here, it showcases where the trip value would be across temperature, and you can see that it varies pretty substantially. So really one of the benefits of the TPS1641 against traditional discrete fuses is the ability to have a very accurate current limit. So if you wanted to have a current limit that was below 15 watts, then you can see in this red curve here that it has a very stable accuracy across temperature, from minus 40 C up to 125 C. So really what that helps to provide is it allows you to maximize the amount of power available for your output. And then quickly going over to some of the other versions that we have, the versions 1.2, 1.3, 1.6, and 1.7 ordables offer adjustable current limiting. So the adjustable current limit can be adjustable from 30 milliamps up to 1.8 amps via an external resistor. And then the device can also offer triggable blanking time for current limit as well, as was discussed in the power limiting device. So depending on whatever value you use for the C delay capacitor, then you can configure the blanking time to allow transients to pass. Now going over to one other unique feature is the added protection against single point failures, if that's required in your systems. So some systems do require protection against these single point failures. And so TPS1641 adds a number of features which enable it to be safe during these single point failures. So the first case we'll analyze is the case A, in case that there's an in to out short across the terminals. The TPS1641 can actually detect when that's occurring by placing a dummy load and determining if current is flowing through its MOSFET. And if not, then the device will actually turn off and signal a fault on the fault pin, which can then be alerted to the MC. So that's one of the first cases where it can provide protection against a single point failure. The second is OVP. So what can be done is with an additional external PFET, you can provide protection up to 60 volts versus overvoltage event. So if you need to shut off if the power supply ever fails, our device can detect that there's an overvoltage event and then shut off this 60 volt PMOS to protect the downstream system. And that's all done with our adjustable OVP mentioned in case B. And then the last but not least is adjacent pin shorts. So for D, if any of the pins short next to each other, our device will remain safe and provide power limiting or current limiting to protect the system from a short circuit. And then something else just to mention, VCC, OVP, and fault pins are all rated up to 60 volts. So they can handle 60 volts if it's ever needed if the power supply can ever go up to 60 volts. So it provides that robust protection. Now to go over to power limiting applications in industrial. The three main applications we'll focus on today are home appliances, medical, and building automation. There could be other applications for power limiting in industrial. So just to touch briefly on home appliances first, really where power limiting can be used is to help reduce system costs and development costs for appliances which need to undergo IEC 60335-1 and UL 6730 certifications. And really how you can do that is by enabling a 15-watt low power circuit. And we'll talk a little bit more about what that means in the next coming slides. Then we'll touch briefly on medical. So to prevent fire in medical equipment with high concentration of oxygen gas, one of the things that's called out in the IEC 60601 section 11.2 is having some type of power limit to 10 VA. So we'll talk a little bit about that in the coming slides as well. And we won't touch on this in the slides, but it kind of is the same application as the home appliances, but with building automation for different actuators or different systems, which also need to undergo this IEC and UL testing. By enabling 15-watt low power circuits, you can also reduce system costs and development costs. Cool. So to dive in a little bit deeper on 15-watt power limiting in appliances, as per the IEC 60335-1 and UL 6730, a low power circuit is defined as a circuit that consumes less than 15 watts of power. So what really are the benefits of having a circuit defined as this? Really what it comes down to is anything below 15 watts is deemed as a low risk of fire. What that really helps to do is forego some tests that are required at a system level. For any circuits that are less than 15 watts, the glow wire test can be exempted, as well as the needle flame test can also be exempted. So that can really help to reduce the number of tests that are needed at the system level when going through certifications. And then the second is reduce system cost. So by having less than 15 watt power limiting, the risk of fire is low. So what this can really help to do is reduce the flame retardants in the plastic enclosure, which can help to save cost. So what's really the benefit of the TPS 1641 with this less than 15 watt power limiting? Really, it comes down to the accuracy of the 1641. So it can provide accurate current limiting or power limiting, a plus or minus 5% 15 watts. So really what this can do is help to maximize the amount of power you can deliver to your output. So as things become more powerful or maybe need higher power, the TPS 1641 ensures that you can maximize the amount of power you can deliver to your output. So taking a look at the bottom left figure, these are some of the different applications within a refrigerator, which could be considered a low power circuit. So the first one is an ice maker. So maybe that's something that could consume less than 15 watts, or maybe interior lighting is another example, or maybe a control panel. So all three of these could be classified as less than 15 watts, depending on the power budgets for those. So if they are, one of the things that could be done is any connectors from where the eFuse or where the protection circuit is placed, anything after that point can be considered a low power circuit. So any plastics along that route after that point can be considered less of a fire risk, and you can help to save some system costs on those plastics. We discussed this more in detail in actually an applications brief that we have on ti.com. So here at the bottom of the slide here, you can go into more details on what the power devices work and help to meet these different requirements. And now going over to medical, the two different end equipments that we'll talk about are ventilators and anesthesia delivery systems. And generally these have different valves which are used to provide oxygen gas. And given oxygen gas is flammable, one of the things that the IEC 60601 section 11.2 calls out is the need for some type of power limit. So 10 VA power limit for the system. So with the TPS1641, this can help to optimize and make sure that you provide maximum power for these different subsystems. Cool. And then now to go over to the TPS1641 and how it can provide backplane power protection. In terms of background, really what backplanes are used for in PLCs is to distribute both power and data to different PLC modules that can be hot swapped in or plugged into the PLC backplane. Generally, these have few components just to increase the lifetime of the product of the backplane. So really any type of protection that would need to be placed in the individual modules themselves. So one of the critical things for backplane requirements is for it to remain active even if a plug-in module fails. So even if one module fails, it shouldn't bring down the whole backplane. So power and data should still be provided to the other modules attached to the backplane. So to achieve this, you need to have some type of localized protection in each of the plug-in modules to make sure that if one fails, it only turns off that module. It doesn't affect the backplane. So really what TPS1641 can do is really help provide optimized protection, both over voltage and over current protection in the case of a module failure. Additionally, our device can also provide inrush current limiting. So if a device is able to be hot swapped into a backplane, our device can provide inrush current control as it charges up the input caps of the module. So it can help to prevent the backplane module from being overburdened from the inrush current. Additionally, the device is available in a very small 3mm by 3mm package. So it can really be used as a small component that doesn't take up much board space to provide this critical protection. And then last but not least, just wanted to sum it up. The TPS 1641 is a very flexible device, so it can operate up to 40 volts. And up to 1.8 amps. And there's 8 different devices that we have, so it can really help to cover a broad range of applications you may have for this device. And really the few applications that we really highlighted here is really how the device can be used to limit power in industrial applications to save costs such as in home appliances, medical equipment, and building automation applications. The device is also optimized to provide backplane power protection in PLC systems. So it can be used as a very small component to provide those functions. So if you'd like any more information, you can visit the product folder on TI.com by typing in TPS1641 to your browser of choice. And you can start evaluating our device by ordering our EVM on TI.com. So in terms of that concludes our new product update. Thank you for the time.
Hello, everyone. I'm Lokesh. Thanks for joining this new product update. And I will be going through the questions that were asked on the chat. So the first question is, which application is suitable for a back-to-back FET topology and which application is suitable for a single FET topology? The applications which are suitable for back-to-back FET topology are the applications which require reverse current blocking, reverse voltage protection, and for the single FET topology, it is majorly the overcurrent protection, overcurrent limiting, and overvoltage protection. The second question is this device certified by UL or TUV agencies? Yes, this device is currently undergoing the UL certification, and it will have the UL 236 certification in next 2 or 3 months. Thanks again for joining the seminar again.